Alright, so now we're in Chapter 1, Unit 4, so let's go over some important stuff that you might want to memorize or just keep note of as we go through the problems. So this unit covers functions. So the first thing we should know is function notation, which is y equals f of x. And you'll probably see f of x equals something like x squared, for example. And this is just to help us when we're in the process of graphing. The next thing we're going to need to know is a piecewise defined function, which is a function that's defined by two or more equations over a specified domain. And as an example, I wrote f of x equals x squared plus 1 when x is less than 0, and x minus 1 when x is greater than or equal to 0. So when we're graphing it, this x squared plus 1, or for every value where x is less than 0, it's going to look sort of like a parabola. But then after 0 and at 0, it's going to start looking like a negative sloping line like that. The other thing we're going to need to know is the domain and range of a function. The domain is all the possible x values of a function, and the range is all the possible y values of a function. The other thing you're going to need to know is the difference quotient. And this is something that you do in Precalculus without having a lot of objective to it or not really knowing why you're doing it. But in the later units of Precalc, and especially in calculus, you're going to use the difference quotient. You're going to use the difference quotient for something called the derivative, which is something we're going to get to later. But for now, we just need to know the difference quotient formula, which is f of x plus h minus f of x over h, and h cannot equal 0. The other thing you need to know is what is a function. And in order to determine if a related set of ordered pairs are a function, is you have to make sure each input has exactly one output. That's the most important thing. If you have one input that has 2 or 3 outputs, it cannot be a function. So those are the important things you need to know for this unit. Now let's get on to the problems. Okay, so in this next problem we're asked if this relationship is a function. And we're given our domain, which is our list of inputs, and our range, which is our list of outputs. So let's see if this is a function. Well, negative 2 has exactly one output to 5. Negative 1 has exactly one output to 8, 0 has one output to 6, 1 has one output to 6, and 2 has one output to 7. So, yes, this is a function. Okay, so in this next question we're asked the exact same thing, but we're given a different domain and a different range. This time we're only given one domain, American League, and 3 ranges or 3 values in the range of Orioles, Yankees, and Twins. So as you can see, this one input has 3 outputs, so this is not a function. Alrighty, so in this next problem, we are asked to determine whether the relation represents y as a function of x, and we're given this input-output table, and basically what this question is asking us to do is to determine if each input has exactly one output. So we can see negative 2 goes to negative 8 and negative 8 only. Negative 1 goes to negative 1. 0 goes to 0. 1 goes to 1. And 2 goes to 8. So it's not like there's another spot over here that says, for example, negative 2 to 4. If it said that, that means we have one input having 2 different outputs. But because we don't have that, because each input has exactly one output, this is a function, or y is a function of x. Okay, so in this next problem we're asked the exact same thing, but we're given a new input-output table. And here you can see this is a little bit different. We see here that 10 outputs to 3 as well as to 15. 7 outputs to 6 as well as to 12. So inputs in this relationship set, in this data set, inputs can have more than one output, which means it's not a function. because in order to be a function, each input must have exactly one output. Okay, so in this next problem we're asked to determine whether the equation represents y as a function of x. And we have our equation as x squared plus y squared equals 4. Now, what I know about this equation is that if you graph it, it's going to come out like a circle. So we can see here, let's say this is the origin. If this is the origin of the graph, or if this is just the graph, I guess, and this is a circle, obviously it might not look like this. I'm just drawing a quick sketch to give an example. And we have this x value over here. This is some x value over here. Well, we can see if we go up, we have another point at that very same x value, meaning that one x value had two y outputs. It had a y2 output and a y1 output. That means it is not a function. Okay, so in this next problem we're asked the exact same thing, and we're even given a very similar equation. This time we're given x squared plus y equals 4. So this one, we're going to make a rough graph of it again. This is going to be some sort of downward facing parabola, and it looks like it's going to be translated some units to the right or left by 4. So let's say I draw this downward facing parabola. Now each x point here, it only has that x point. It's not like at the circle. It's not like the circle where an x point here had a two y values here and here. An x value here means a y value here, and that's it. Meaning each x input has exactly one y output. So yes, this is a function. Okay, so in this next problem we are asked to determine whether the equation represents y as a function of x, and we're given this equation, 2x plus 3y equals 4. So what I'm going to do is put it into a form that I'm more familiar with. I'm going to subtract 2x from both sides, and I'm going to have 3y equals negative 2x plus 4. And then I'm going to divide by 3 on both sides, and I'm left with y equals negative 2/3 x plus 4/3. Now I can see this is a line with a y-intercept at 0, 4/3, and it's downward sloping with a slope of negative 2/3. So let's just draw like this. And you can see here, each x value has only one y value. And this question is basically asking, is the relationship a function? Do we have one y for each x, one output for every input? Does each input have exactly one output? And we can say that yes, it is a function. Each input has exactly one output. Okay, so in this next problem we're asked the exact same thing, but we're given a different equation. This time our equation is x plus 2 squared plus y minus 1 squared equals 25. And I already know that this is going to come out in a circle because the equation for a circle is x minus h squared plus y minus k squared equals r squared. So I know this is going to be a circle with a center at negative 2, 1 and a radius of 5. I'm not going to graph it exactly, but I'm just going to graph the general shape of a circle. So negative 2, 1, radius of 5, let's just say it's there. Once again, at this x value here, for example, I have two y values. One input is having two outputs, which means this cannot be a function. Okay, so in this next problem, I'm asked the exact same thing, but a different equation. So now that you've seen how to do the last few, I want you to pause this one try it on your own, and we'll come back and see how you did. So assuming you've tried this on your own, let's see how you did. So once again, this is the equation of a circle. This time our center is going to be at 2, 0, it looks like, and our radius is going to be 2. So if our thing is at 2, 0, it's going to be like here-ish, I guess. I'm not drawing it exactly, just a rough sketch to show the idea. And we can see, just as the last few that were circles, one input can end up having more than one output, which means any equation of a circle cannot be a function. Okay, so in this next problem, we're given the same question but a different equation. This time our equation is y equals the square root of 16 minus x squared, and 16 minus x squared is all under the radical. So if we're going to graph this equation, we need to understand that its domain is kind of limited in what it can be. First of all, it can only go up to x equals 4. At x equals 4, let's say this is 4 right here, this is what happens at x equals 4. We get 16 minus 4 squared, which is 16. 16 minus 16 is 0, and that would be 0 right there. If we go x equals 5, for example, we get 16 minus 25, which is the square root of -9, which is an imaginary number, which we can't graph on the real number plane, which this is. So it can only go up to 4, and it can go this way though. It can x has to be less than or equal to 4 essentially. It can be well, let's test it out. Can it be -5? 16 minus -5 squared. That's going to be 16 minus 25. Okay, so it can't be, it has to be between -4 and 4, it's looking like. Because if we plug in -5, for example, then we get another imaginary number. At -4 though, if I'm correct, 16 minus -4 squared, we're going to get 16 minus 16, and that's going to be 0. Okay, so our graph is going to look something like this. But as you can see, it's defined in a certain range. Didn't mean to write that. Or its domain is limited in what it can be. But every x value has only one y value that corresponds with it that satisfies the equation. Each input only has one output. So yes, this is a function. Okay, so in this next question, we're asked to determine whether the equation represents y as a function of x, and our equation is y equals the absolute value of 4 minus x. So I don't even have to graph this exactly, I can just draw a rough sketch of what I know it would look like. So this is an absolute value equation shifted 4 to the right, so it would look something like this, assuming that this point here is 4. It would look something like this. Now if we look here, each input, each x value has only one y value, one output. So since we can confirm that each input has exactly one output, we can say that yes, this is a function. Okay, so in this next problem we are asked the exact same thing, but this time we're given a different equation. Our equation now is x equals 14. Now I'm gonna go ahead and say right now that this is not a function, and there are two ways you can kind of reason out that this is not a function. The first way is that it asks whether the equation represents y as a function of x. Well, there is no y here. We cannot represent y as a function of x if there is no y. The other reason it's not a function is if we graph it, if we were to graph it, it would be
let's say 14 is over here, for example, it would be this up and down line like this, and we'd see that the input of 14 has infinitely many outputs, because right here our input is 14, but our output could be negative 14. Here our input is 14, but our output is 0. Here our input is 14, but it could be positive 15 on the y value. So that's another reason why this would not be a function. Okay, so in this next problem we are asked the exact same thing, but this time our equation is y plus 5 equals 0. I'm going to change this into y equals negative 5 really quickly, and then I'm going to graph this to show you why it would be a function. So let's say this point down here is negative 5. And so we have this horizontal line going like this, infinitely in the positive direction and infinitely in the negative direction. We can still see though that at x equals 1 our point is negative 5. And it's only negative 5. It's you can't have a pair of 1 comma negative 3, for example, because negative 3 is right here, and that's not on the horizontal line. If we go x equals 2, it's the same thing. Our y value is negative 5. Our output will be the same for every input, but each input will only have one output, if that makes any sense. Your outputs can be the same. One output can have more than one input, but it cannot go the other way around. In order to be a function, each input must have exactly one output, and that is the case here, meaning this is a function. Okay, so in this next problem we are asked to evaluate the function at each specified value of the independent variable and simplify. And our function is f of x equals 2x minus 3, and they want us to evaluate it at f of 1 and f of negative 3. Now, when I first learned about functions, the whole f of x thing really confused me. So I just want to go over and explain it. Basically, you can f of x means the function evaluated at x. So it means this is the function and evaluate it at a certain x value. In this case, they want us to evaluate it at 1 and negative 3. There's also a rule which says y equals f of x, meaning if you're going to graph this or something like that, you can just replace the f of x with y, and you get y equals 2x minus 3. So whenever you see evaluated at f of a certain number, it just means plug that number into the x wherever you see x in the equation. So for f of 1, I'm going to write f of 1 equals 2 times 1 minus 3. 2 times 1 is just 2, so you have 2 minus 3, and 2 minus 3 is negative 1. So this function evaluated at the x value 1 is negative 1, meaning if we were to graph this, our ordered pair would be 1 comma negative 1. So now we go to f of negative 3. And I'm going to write f of negative 3 equals 2 times negative 3 minus 3. 2 times negative 3 is negative 6, so we have negative 6 minus 3, which is negative 9. So these two values here are this function evaluated at the x value 1 and the x value negative 3. Alrighty, so in this next problem we are asked to evaluate the function at each specified value of the independent variable and simplify. And the function we're given is v of r equals 4/3 pi r cubed. And our different values that we have to evaluate this function are v of 3, v of 3 halves, and v of 2r. So I'm just going to start with the first one, v of 3. So just like these last problems with this, you're going to plug in 3 whenever you see r. That's basically all it's saying. It's saying, and what this means is the function v evaluated at r. That's what you're saying when you say v of r, or when I say v of 3, for example, I'm saying what is the function evaluated at r equals 3. So I'm going to do v of 3 equals 4/3 pi, oh that's a bad pi, and then I'm going to substitute the r with the 3, and I'm going to cube it. Well, order of operations tell me that I'm going to have to cube this 3 first, so I'm going to have 4/3 pi times 27, and I'm just going to write it like this. Now, multiplication is commutable, I believe the term is, meaning 4/3 times pi times 27 is the same thing as 4/3 times 27 times pi. So I'm going to quickly rewrite it as that latter way, just because I'm going to do something in the next step here that might be easier to see how I'm doing it if the 27 is by the 4/3. And I'm going to also write in the multiplication symbols, even though they're implied in this step, I'm going to show them here. I'm also going to write this as 27 over 1, and then what I'm going to do is I'm going to cross-reduce that. So I'm going to divide the denominator of 4/3 by 3, so 3 divided by 3 is 1, and 27 divided by 3 is 9. So I'm going to have 4 times 9 pi, which is 36 pi. And that's our answer for part A. Now if we erase all that, and then we are going to do part B now, we have v of 3 halves, and we're going to do the exact same thing here. We're going to do 4/3 times, I guess I don't need that, just 4/3 times pi, times 3 halves cubed. Now, the interesting thing about exponents, if you didn't know this, is that if it's going to a fraction like this, for example, I'll write the property out, a over b cubed is equal to a cubed over b cubed. Meaning 3 halves cubed is the same thing as 3 cubed over 2 cubed. So that's what I'm going to write. I'm going to write 4/3 pi times 3 cubed over 2 cubed. And then I'm going to write 4/3 pi, and then 3 cubed, as we saw in the last problem, is 27, and 2 cubed is 8. Now, at this point I'm going to cross-reduce these fractions, but I'm not going to take the extra step to move them over, because you just saw that, so you know how I'm doing this. But basically this 3 is going to be divided by 3 to become 1, and this 27 is going to be divided by 3 to become 9. And then this 4 is going to be divided by 4 to become 1, and this 8 is going to be divided by 4 to become 2. And that's going to leave me with 9 over 2 pi. And that's the answer for part B. Alright, so now let's do part C then. V of 2r. So this is different from the other problems in that the other problems didn't have an r in them, so you could get an answer. This one, however, has an r in it, so we're going to get an answer, but our answer is going to have an r in it. And I'm just just saying that so you don't think that you accidentally got the wrong answer, because yours still has an r in it. this is supposed to have an r. So I'm going to write 4/3 pi times 2r cubed. Then we're going to simplify that as 4/3 pi times 8r cubed. And that 8 and that r cubed comes from me distributing this cube, this exponent, this raising to the 3, distributing it to both of these numbers within the parentheses. So 2 cubed is 8 and r cubed is just r cubed. So then we're going to be left with, and we can't cross-reduce this either, like the other problems, so I'm just going to multiply straight across. So this is technically pi over 1, this is 8 over 1, and this is r cubed over 1. So 4 times 8 is 32, and then I'm just going to tack on the pi r cubed at the end, and 3 times 1 times 1 times 1 is just 3. So it's a little bit of a cumbersome fraction, but ultimately in the end your answer is going to be 32 pi r cubed over 3 for part C. Alright, so in this next problem we are asked the exact same question, but we're given a different function and different values to evaluate it at. So our function now is g of t equals 4t squared minus 3t plus 5, and our values to evaluate it at are g of 2, g of t minus 2, and g of t minus minus g of 2. So once again, I'm just going to start with part A here, and we're going to do g of 2. And just like all the previous problems, we're just going to plug in 2 wherever we see t, because we are evaluating the function g at t equals 2. So I'm going to have 4 times 2 squared minus 3 times 2 plus 5. Well, we're going to have to evaluate this 2 squared first, so that's going to be 4 times 4. And then we can go ahead and include this 3 times 2 in the next step, or kind of in one step, because we'd just be doing that pretty soon anyways. So it's going to be minus 6 and plus 5. 4 times 4 is 16, so we're going to have 16 minus 6 plus 5. 16 minus 6 is just 10, so we have 10 plus 5, and 10 plus 5 is of course 15. So that would be your answer for part A. But now we have part B, which says g of t minus 2. And this is similar to the last problem where we had v of, I think it was 2r, I believe. This is going to be similar in that we're going to have a t in the answer. It's not going to be a single number. We're going to still have a variable in our answer, and that's okay. So I'm going to do 4 t minus 2 squared minus 3 t minus 2, I mean, plus 5. So when we have this t minus 2 squared here, we can just write that, if this is easier for you to see, and I know for me it is easier to see it this way, as just t minus 2 squared. Or t minus, of course it's t minus 2 squared, but you would write t minus 2 times t minus 2. And then we'd have minus 3 times t minus 2 plus 5. And I know there are a lot of numbers and variables here, but it's going to be pretty straightforward. I'm going to FOIL this this t minus 2 squared here, and if you don't know what foiling is, it's a mnemonic device to help you remember how to square a binomial, I suppose this would be. So maybe this is monomial, I don't know, I'm not too familiar, if I'm honest. So anyways, it stands for, this F stands for first, because you're going to multiply the first thing by the first thing, I guess the first thing in the parentheses by the first thing in the other parentheses. The outside is the O, because you go here, and then you go inside, so like that. It's the smallest one, so it's the inside, and then the last. That's what FOIL stands for. So I'm going to do 4, and then I have to do t times t, which is t squared. And then I'm going to do t times negative 2, which is negative 2t. And then I'm going to do negative 2t again. And then I'm going to do negative 2 times negative 2, so that's plus 4. And then I'm going to distribute this negative 3 to this t minus 2 over here, so I'm going to be left with minus 3t plus 6 plus 5. So now I'm just going to distribute this 4 to all the t. Actually, before I do that, this really quickly is going to be negative 4t. So now I'm going to distribute the 4, so I'm going to have 4 t squared, let me write a better t, 4 t squared minus 8t minus 8t, not minus 8t, it would be minus 16t plus 16. Then we'd have this minus 3t plus 6 plus 5. Now we just have to look at which terms we can, which like terms we can combine and simplify. So already I see we have negative 16t and negative 3t, so that's going to be negative 19t right there. And then I see we have 16 plus 6, so that's going to be 22. And then 22 plus 5 is going to be 27. So we're going to have 4t squared minus 19t plus 27. And this is a 9, not an A. 4t squared minus 19t plus 27. And it's important that you write it in this way because if you're writing in any polynomial, any nth term polynomial, you have to write it in descending order, which means write it from highest exponent to lowest exponent. So we go from t squared to t to no t. There's 0 t's by the 27. So that would be your answer for part B. So then if we go to part C now, we're going to have, and this one looks even more difficult, but it's going to be just as straightforward as the other ones. We're going to have g of t squared, not t of squared, it's just g of t minus g of 2. Now, we already found a g of 2 in part A, but I forgot that because I erased it from the screen, so I'm just going to quickly plug 2 in for those t's in my calculator and see what the result yields. 15, right. So, with this one, it's going to be just the way it looks. This is g of t right here. So we're going to write the whole 4t squared minus 3t plus 5 minus 15. And then we're just going to combine like terms, which the only like terms here are 5 and negative 15, which are going to combine to give us 4t squared minus 3t minus 10. And that's literally it. It was probably the shortest one of these problems, yet it was designed to look very difficult. But like I said, it was straightforward, and that's how you do that one.